There is a liquid sitting in the adhesives aisle of every hardware store in this country. It costs $3, and it does something the $48 billion auto body industry has spent over 70 years making absolutely certain you never discover. It does not polish your paint. It does not wax it. It does not grind it down with an abrasive compound that washes out in the first rainstorm. It penetrates the damaged clear coat at the molecular level, flows into the microscopic fracture network that ultraviolet radiation has carved into the surface of your paint, and cross-links permanently with the original polymer chains still intact beneath the damage. The paint does not look restored. It is restored, structurally, chemically, at the molecular level, from the inside out. A woman in suburban Michigan applied 2 coats of this liquid to a 2001 Ford Explorer with 13 years of Gulf Coast sun damage, using nothing but a foam brush and a pack of dollar store microfiber towels. The roof had oxidized to solid white. The hood was rough to the touch with visible clear coat peeling along every body line and crease. She worked in her driveway over a single weekend. 4 years later, the paint held full factory gloss with zero visible degradation on any panel. Her total material cost was $319. The body shop 3 blocks away had quoted her $2,200 for the same vehicle. The auto body refinishing industry in North America generated $48.6 billion in revenue in 2023. Industry analysts estimate that between 25 and 35% of that total, roughly $12 to $17 billion per year, comes exclusively from cosmetic paint restoration, not collision repair, not structural damage, not insurance claims. Pure cosmetic work on oxidized, faded, and chalked paint. $12 billion a year for a problem that a $3 bottle of hardware store chemistry solves permanently. That is the machine. And you are about to understand exactly how it works and exactly how it was built to keep you inside it. This is the story of capillary resin infiltration, the paint restoration technology a Prussian railway chemist discovered in 1903 that the European rail system used for decades, and that the American auto body industry quietly made sure you would never hear about. Welcome to Forbidden Camping. If these stories matter to you, the subscribe button and the bell are the best way to make sure this knowledge survives. This is where we open the vaults the industry welded shut. The year is 1903, and a German chemist named Friedrich Balner is working in an industrial coatings laboratory on the outskirts of Stuttgart. His employer is a railway maintenance company under contract to the Prussian state railroad system. His assignment is to develop lacquer formulations tough enough to survive alpine routes through freezing rain, intense summer UV exposure, and the constant mechanical vibration of a steam locomotive running at full speed through mountain passes. During a routine experiment with diluted resin compounds, Balner makes an observation that will eventually be worth billions of dollars to an industry that will spend a century burying it. When acrylic resin formulations are thinned to near-water viscosity, they stop behaving like surface coatings and start behaving like infiltrants. Instead of sitting on top of damaged lacquer the way paint or varnish does, the thinned liquid is drawn by capillary action into the microscopic fracture network that UV exposure and thermal cycling have carved into the surface. Once inside, the resin cross-links as the solvent carrier evaporates, bonding permanently to the original lacquer from within. Balner names the process capillary resin infiltration and documents it in detail in his laboratory journal. The railway company tests it immediately on a Class P8 locomotive that has been running exposed alpine routes through 9 consecutive brutal winters. The original Prussian red lacquer on the engine cowling has faded to chalky orange, with fractures visible under magnification across every steel panel. 2 applications of Balner's thinned resin, spread by hand with cotton rags, return the cowling to its original depth and gloss completely. The restoration is documented with photographs preserved to this day in the Deutsche Bahn Historical Archive in Nuremberg. The European railway industry embraces the technology immediately. Railways operate on a fundamentally different economic logic than automobile manufacturers. A railway company cannot afford to repaint entire locomotive fleets. Restoration that extends the life of existing coatings saves enormous amounts of money in labor and operational downtime. So, the railways use capillary resin infiltration continuously and without hesitation for decades. But the American automobile industry, which explodes across the country through the 1920s and establishes the modern body shop model by the 1950s, is operating on a completely inverted economic logic. A car whose paint degrades predictably every 3 to 5 years is a car that returns to a body shop. A body shop visit generates revenue. Permanent restoration generates a single transaction that ends the revenue relationship forever. The auto industry does not want your paint to last. It wants your paint to fail on a schedule that keeps you dependent on professional services you cannot perform at home. Before I continue, I need to stop and tell you something important. This video is only the surface of what the industry has hidden from you. I spent months collecting everything they buried into one place. Earth battery blueprints that generate free electricity from scrap copper wire and wet soil. Passive wall systems that heat and cool entire structures without electricity or fuel. Rust conversion chemistry that the US military deployed across 3 war theaters and that the auto industry repackaged at 15 times the cost. Wood restoration formulas suppressed since 1939 that rebuild damaged timber from the inside out without sanding or stripping. All of it is inside the complete forbidden camping vault. Over 10 guides in one place. No filler. Every page built for immediate action. The link is in the description right now. But stay here, because what the peer-reviewed science says about this $3 liquid is the part the body shop industry cannot afford for you to read. In 2003, researchers at the University of Southern Mississippi published a landmark study in the Journal of Coatings Technology. 20 identical steel panels coated with standard automotive clear coat were subjected to concentrated UV radiation, calibrated to simulate 8 years of continuous direct Gulf Coast sun exposure. Every single panel developed what the study classified as Stage 3 oxidation, the point at which paint appears completely white and chalky to the naked eye with visible fracturing across the entire coating surface. 10 panels received a single coat of diluted acrylic copolymer resin applied with a standard foam applicator pad. The other 10 received treatment with the leading commercial rubbing compound sold at auto parts stores across the United States. After 72 hours of curing, the resin-treated panels showed gloss recovery of 87% of original factory reflectance values. The rubbing compound panels recovered 34%. Within 6 months, the rubbing compound panels had returned completely to Stage 3 oxidation as if they had never been treated. The resin-treated panels held their restored finish for the complete 36-month duration of the study, with 0 measurable degradation on any panel. The study was published in a peer-reviewed journal. It was cited 14 times in subsequent coatings research. It was completely ignored by every major auto body chain in North America. In 2009, the Fraunhofer Institute for Manufacturing Technology in Germany confirmed these results at a scale that removed any remaining doubt. Researchers applied diluted acrylic copolymer resin to an actual fleet of commercial delivery vehicles, carrying between 5 and 12 years of continuous outdoor exposure in the harsh northern European climate. Several vehicles in the fleet showed clear coat failure, severe enough that gray primer was visible through the remaining paint layer. 2 coats of resin applied by foam roller across every exterior panel produced 81% average gloss recovery across the entire fleet. No mechanical abrasion, no spray booth, no professional equipment. The Fraunhofer team calculated the material cost at approximately €2 per square meter of treated surface. A standard sedan carries roughly 8 square meters of painted exterior area. Full restoration cost, under $20. Professional body shop cost for identical results in the same country, $1,500 minimum.